to welcome you to today's ECONtribute webinar of our Cluster of Excellence of ECONtribute, Markets and Public Policy. My name is Thomas Domen. I'm one of the two spokespersons of the cluster. Before we start, and before I will introduce the Cluster of Excellence to you and our speaker, Florian Zimmermann, I would like to provide some information on organizational details. First, I would like to inform you that we record this webinar and plan to make it available on our ECONtribute website in the future. So if you do not want to be visible and or identifiable, you should turn off your camera. You should probably also change your profile picture and potentially change your username. You could do so, for instance, by setting it to participant. Second, I would also like to ask all of you, and most of you have done so already, to turn off your cameras and your microphone during the presentation by Florian. Third, I would like to ask you to abstain from asking questions directly during the 30-minute presentation that will follow. But instead, I would encourage you to send your questions during the presentation to the host of the meeting by using the chat function in Zoom. We will then collect all questions and I will raise them after the 30-minute presentation. We'll then have roughly 15 minutes for discussion. And now I guess we are all ready to start. So again, I would like to cordially welcome you as participants to today's ECONtribute webinar of our Cluster of Excellence ECONtribute, Markets and Public Policy. I would also like to warmly welcome our distinguished speaker, Florian Zimmermann. Florian is a member of our cluster. Let me start by saying a few words about our recently founded Cluster of Excellence. The cluster is a research collaboration between the Universities of Cologne and Bonn, as well as the Max Planck Institutes for Research on Collective Goods and the Brick Institute in Bonn. The cluster is funded by the German Research Foundation within the German Excellence Strategy, and it is the only cluster initiative in the area of economics. The cluster deals with the functioning and failure of markets. The conventional approach in economics is to assume that markets generally produce desirable outcomes, but that there may be market failures that lead, for example, to financial crises, to pollution, to inequality, and so forth. The goal of the Cluster of Excellence is to advance a new paradigm for the analysis of markets and public policy in light of many pressing fundamental societal and technological challenges. And such challenges can, in our view, not be fully understood by relying on traditional economic approaches that, for instance, emphasize market power externalities, information asymmetries as sources of market failures, and that have typically a very narrow view on the nature of human motivation, oftentimes assuming that agents are selfish, rational, forward-looking, and that they form unbiased beliefs about the future. Florian Zimmermann's approach deviates from that traditional view in that in his work he studies how beliefs, which are very relevant for economic behavior decision-making, are formed. His work highlights the role of personal experiences, bounded rationality, cognitive biases, and memory on the formation of beliefs. Before I hand over to our speaker, let me say a few words about him. Florian studied economics at the University of Mannheim and UCLA. He received his PhD in 2013 from the University of Bonn. And then he worked as a postdoc at the University of Zurich and as a visiting fellow at Harvard University, before he then returned to Bonn as a professor of economics in 2017. Florian contributes to our research area, Behavioral Foundation. And his research focuses on the formation of beliefs. Studying the formation of beliefs is important as beliefs shape economic behavior. Distorted beliefs could lead to suboptimal outcomes or even induce economic crises. It has been argued, for example, that the financial crisis was induced by suboptimal beliefs or distorted beliefs. Hence, it is important to know whether individuals use Bayesian updating to process information or whether they deviate from that rational benchmark. And if they deviate, in what ways? So we are curious to hear what this is all about. Florian, the next 30 minutes are yours.
Okay, great. Thanks a lot, Thomas. Well, thanks to the organizer for hosting me here. I want to start spending a
Florian,
couple.
You can start.
Ah, yes. You can't hear me? Hello?
Yes, we
can.
can.
You hear me?
We can hear you.
We can hear you, yes.
Ah, sorry. Okay, so let me start over. Thanks, Thomas, for this very nice introduction, and thanks to the organizers. I want to start with telling you a little bit about what you can expect today, so that you can make an informed choice to leave the presentation at any point. So the purpose of this talk and this rather new or very new seminar series is actually twofold. The first goal is, of course, to present and talk about research, but the other goal, as Thomas alluded to, is also to introduce the excellence cluster. So I want to briefly talk about sort of my broader research agenda, at least the aspects that are part of the cluster, but only for 3 slides actually. And then I'm going to move to the main part of the talk, where I want to talk about a recent paper that is joined with Benny Enke and Frederik Schwerter, and is called Associative Memory and Belief Formation. And to sort of give you a very brief preview of what we're going to do here is in this paper, we sort of introduce basic insights from memory research into the study of belief formation processes. We're going to formulate a very simple model based on existing models of how memory can shape the belief formation process. And then in the main part, we're going to introduce a new experiment to study the role of associative memory for belief formation. And to sort of give you a quick preview of our main findings, we're going to show that associative recall can actually predictably generate both over but also under reaction to news. And we're going to really isolate the role of memory, and in particular associative memory, in generating this over and under reaction. Now, as I said already, sort of as Thomas alluded to, sort of the broader research agenda that is part of the cluster basically focuses on the question of what actually determines beliefs, how are people actually forming their beliefs. So you might ask, sort of, why should we actually study beliefs? And sort of on a very basic level, I think the answer is that a core feature of much of economic analysis is simply that people are forward-looking, and that we assume them to form beliefs and expectations about the future. So on this very basic level, this already makes beliefs potentially an interesting object to study. There's many research that sort of empirical research that sort of highlights the importance of beliefs for economic behavior. Here I'm providing a very, very, very selective overview. So there's really dozens of papers in that spirit that really highlight the important role of beliefs. So I'm really not doing them justice here at all, and I apologize for that. I wanted to highlight two papers that look at beliefs, the role of beliefs for individual behavior. The first is a series of papers by Malmendier and Tate, where they show that over-optimistic beliefs actually distort or can distort corporate investment and merger decisions by managers and CEOs. There's a very nice paper by Johannes Spinnewein that argues that distorted beliefs can actually lead job seekers to exert suboptimally low search effort. But there's also evidence that suggests that beliefs might actually also matter on the aggregate. By very prominent scholars, for instance, Eckloff and Schiller, have argued that cycles of overly optimistic and overly pessimistic beliefs are actually key drivers of boom and bust cycles. Giannaioli and Schleifer, in a recent book, argue that mistaken beliefs were actually key drivers of the financial crisis. So if you follow me that beliefs are sort of an important object to study, then a broader question that I think immediately comes to mind is, well, actually then what determines beliefs? How are people actually forming their beliefs? And so the general goal here is simply to understand how people form their beliefs. Now, we do have a rational benchmark for this. We do have a rational benchmark for information processing, which is simply Bayesian updating. But we know, at least since sort of the heuristics and biases program of Kahneman and Tversky, that people frequently do seem to deviate from Bayes' rule, which then raises the question, well, if they are not Bayesian, then what are they? What exactly do they do? So the sort of the overarching hope of this agenda is to develop psychologically realistic notions of what people are actually doing when they form beliefs. And the paper I'm going to talk about now nicely fits into this broader agenda and attempts to incorporate memory patterns in the belief formation process to really better understand how people actually form their beliefs. So as I said, the title of the paper is Associative Memory and Belief Formation. It's joined with Benny Enke and Freddy Schwerter. And the basic motivation from this paper comes from two rather simple observations. The first observation is that if you look at the textbook model of Bayesian updating, and in this model, memory imperfections essentially play no role, right? So what we typically assume is that agents entertain a prior belief, and then they update this belief upon receipt of new information. And if we think about this in sort of a dynamic context, then what we assume is that yesterday posterior equals today's prior. Okay. Now, intuitively, if you think about yourself trying to form a belief, trying to form an opinion about something, then most of the time, or at least in many instances, you will actually consult your memory. So you will actually ask yourself, well, what do I know about this topic? Which information have I received about this topic in the past? Which experiences have I made in the past that might be relevant for this specific question at hand? So you do try to reconstruct prior knowledge and information from memory. And very often you will realize that, of course, your memory is not perfect. So for instance, you might not or only imperfectly recall the prior you were holding in the past, or you might not or only imperfectly recall past signals that you've seen. Now, there is a literature on experience effects that clearly suggests that the past somehow matters for expectation formation, in particular by a literature by Malmendier and Nagel, but we don't really know exactly how actually memory plays into the formation of beliefs. The second observation is also very simple, and it's simply that typically real-world signals do not just consist of abstract informative events, right? Instead, information is very often embedded in what you might call memorable context. So this could be stories, images, but also emotions or sounds, right? So think about yourself reading a newspaper article, then the information that is contained in this article is not just given to you in very abstract form, but it's embedded in a context. For instance, the article that the journalist has written, and maybe also a story that is attached to the whole article. So typically, information is embedded in the context, and now, importantly, for the purposes of this talk, similar news are often embedded in similar contexts. Okay, so think about a situation where good news prevail in the stock market, or let's say the housing market, then typically people are exposed to contexts like bulls, upward sloping trend lines, or sort of good time stories. On the opposite, when bad news prevail in the stock or housing market, then people are exposed to bears, downward sloping trend lines, or sort of stories of, you know, families that just got bankrupt or something like that. But the important point is similar news are embedded in similar contexts. Another example would be individuals that actually receive feedback about their own performance, right? So think of a situation where somebody receives negative feedback about his or her own importance, say in school or at work, then very often these negative news are going to be embedded in memorable contexts such as scolding, emotions of public shaming, or, you know, emotions of insufficiency. On the other hand, if the feedback is positive, then this might often be embedded in memorable contexts such as public appraisal or emotions of joy and happiness. But again, the important point is that similar news are going to be embedded in similar contexts. And so what we do in this project is we essentially take these two observations as point of departure And we asked the question of how does associative memory actually shape the belief formation process? Now, the principle of associative recall is really one of the core principles that comes out of memory research. And it basically just says that the recall of memory traces is triggered by cues that are mentally associated with the trace. So an example would be you observe something and that reminds you of something that is mentally associated with the cue. So you hear a song in the radio and that reminds you maybe of the last time you heard this song when you were young, or a couple of years ago, say. Now, the similarity of context plays a very important role for associative recall, because it, at least in parts, determines the strength of these associations. What this means is that a specific cue is going to be more likely to trigger the recall of some memory trace if the context in which this cue is embedded is similar to the context in which the past news was embedded, in which the memory trace was embedded. So the similarity of context plays an important role. Now, this principle of associative recall has received some attention in the recent or somewhat recent theory literature, in particular in a paper by Sandel Mulanathan, and also in a recent paper by Bordalo, Gennaioli, and Schleifer. And sort of the central, or one central prediction that comes out of this body of work is that similarity-based associative recall could cause overreaction to news. So let me show you the very basic intuition for this in a very stylized example. So think of a decision maker that is prompted to form a belief. Now, this decision maker has received some news in the past, and then after receipt of a final piece of news, our decision maker attempts to reconstruct past knowledge, past information that he or she saw from memory. Okay, so the decision, or the context we have in mind, is as follows. Think of the past here as follows. In the past, our decision maker has received a couple of positive and a couple of negative pieces of information. And for the sake of this example, let's visualize context here in the following way. Let's say that positive news are embedded in sort of a red context, and negative news are embedded in sort of a blue context. Okay, now some time elapses, and now in the presence, our decision maker is asked to form a belief after the arrival of a final piece of news. Now, our decision maker is going to try to reconstruct the prior knowledge from memory. So he's going to try to remember, well, what information did I actually see in the past? And this retrieval process is going to be guided by similarity-based associative recall. Okay, so our decision maker is going to remember is going to be more likely to remember past news whose context is similar to today's news, which captures the essence of similarity-based associative recall. So, for example, assume that the final piece of news is negative, then due to the similarity of the context of negative news, our decision maker is going to be more likely to remember the negative piece of news he or she has seen in the past. If the final piece of news is positive, our decision maker is going to be more likely to remember the positive pieces of news he or she has seen in the past. And then as a consequence, expectations of our decision makers are going to look like they overreact to recent news, right? Because again, think of the example where the last piece of news is negative. Because of this selective or asymmetric recall process where our decision maker is going to be more likely to now remember the negative news he has seen in the past, he's actually going to be overly optimistic about the state of the world. If the last piece of news is positive, he's going to be overly optimistic about the state of the world. And so as a consequence, beliefs fluctuate too much based on the last piece of news that you've seen. And as a consequence, they look like you're actually overreacting to the last piece of news. But it's not an overreaction in the traditional sense that you put too much weight on this last piece of news per se. It's overreaction that is generated by this process of associative recall. Okay? So now what we do in this paper is we try to run experiments to study the role of the potential role of associative recall for belief formation. We're going to base our experiments on a stylized model that is essentially a version of Mulanathan and Bordalo et al. And we're going to provide direct evidence from sort of a new, relatively new experimental paradigm in relation to this emerging body of theoretical work. So in a sense, you could interpret our findings as providing evidence for key insights in this relatively new theoretical work. We're going to provide evidence for overreaction, which nicely relates to recent work by Augenblick and Rabin, Augenblick and Lazos, and also a recent paper by Bodalo, or 2 recent papers by Bodalo and co-authors. And we're going to provide sort of a micro foundation for why you might actually see overreaction in this setting. Importantly, we're going to try to experimentally isolate the role of context and associative recall. So we really want to pin down that it's associative recall that is generating overreaction. Now, interesting, as we're going to see in the formal framework, associative recall can actually also generate underreaction in very specific situations, and we're going to provide evidence for that. In the paper, we actually also show that the resulting belief distortions that we get out of associative recall directly translate into corresponding economic behaviors. In the interest of time, I'm not going to show you that, and I'm also not going to show you how we directly estimate the simple model we're going to get simply in the interest of time. All right, so what I'm going to do in the next couple of minutes, I'm going to very briefly talk about the memory model that we put together. I'm really not going to spend too much time on this in the interest of time, but I have to go through the model at least quickly, because the final belief equation that we get out of the model is going to be crucial because it's going to guide our experimental analysis. So the model is rather straightforward. There's a decision maker who tries to form beliefs about some state of the world theta. There's going to be 2 periods, which you could think of the past and the present. The value of this state is given by a very, very simple process. It's given by some initial value v plus the sum of all news that have accumulated up to this point. Now, news can either be positive and negative. Say, for instance, they could either be +10 or -10. That's going to be the case we're going to look at in the experiment. Now, in the first period, our decision maker receives a total of k pieces of news. And then in the second period, a final piece of news may arrive, such that the true state of the world is going to be given by this very simple additive term, which is just the sum of the baseline value plus the last piece of news plus the sum of the pieces of news that you've seen in the past. So very simple process. Now, positive and negative news are going to be embedded in separate contexts. In the experiment, this is going to become very clear. For the purpose of this model, I just want to point out, and I want you to remember that in the model, there's going to be a parameter rho that sort of guides the relation between context and news. And we're going to distinguish 2 cases. One where rho is going to be set to 1, which essentially means that we're going to look at the context at the situation that I used in the opening examples, which is situations where similar news are embedded in similar contexts. Okay, so that means that the contexts that are attached to news in period 1 are going to be the same contexts that are going to be used in period 2. And again, similar news are always going to be embedded in similar contexts. We're also going to look at another case where rho is equal to -1. And in that situation, in period 2, we're actually flipping the relation between context and news. So now context and news in period 2 are going to be associated in the opposite way as in period 1. Again, this is going to become more clear when I talk about the experiment, but it's something to keep in mind right now, because this is going to be the cases that determine whether people are actually going to overreact to news or underreact to news. All right, so now I need to tell you what we assume about the recall, or how we formalize the recall process. We're going to say that in t equals 2, when prompted to form a belief, our decision maker is going to try to recall the news he has seen in the past, so in period 1. As a consequence, beliefs in period 2 are going to be given by the following formula. They're going to be given by the baseline value plus the last piece of news you've seen, plus the sum of all the pieces of news that you've seen in period 1, weighted by whether you're going to remember them or not, right? So for each piece of news, there's going to be some probability with which you're going to remember that last that piece of news. And so now we're going to zoom into this factor x. We're going to zoom into the probability of remembering a specific piece of news that you've seen in the past. Okay, so what we assume here is that the probability of remembering a specific piece of news that you've seen in the past, say this piece of news nx, And the probability of remembering is going to be given by the sum of the baseline probability for recalling. So we just assume that, you know, with some probability, you're just forgetting stuff. And with the remaining probability, you're just going to remember. Plus, if the context in which the current piece of news, nk+1, is embedded, is the same context as the news nx was embedded in, then due to the principle of associative recall, there's an added probability of remembering, and this is going to be given by 1 minus r times a. Okay, so let me make this clear one more time. If the context in which the current piece of news nk+1 is embedded is a different context than the context in which the piece of news nx was embedded, then the probability of remembering is going to be simply given by the baseline probability r. If the context in which the current piece of news is embedded is the same context in which the piece of news nx was embedded, then there's going to be an added probability. So the total probability of remembering is going to be given by r plus 1 minus r times a. And that's going to be the principle of context-based associative recall. You're going to be more likely to remember past pieces of news that were embedded in the same context as the current piece of news you're observing. Okay, and so now with some very simple algebra, what you get is the following belief equation, which has a relatively straightforward form. So if memory is guided by the process that I was just introducing, then the period 2 beliefs are going to be given by the baseline value plus the sum of all pieces of news you've seen in the past weighted by the baseline probability of remembering plus the last piece of news weighted by this expression here. Okay, and so this expression here is going to be the crucial expression, because this expression here determines the weight you essentially put on the last piece of news. So this is the expression that determines whether you overreact or underreact to the last piece of news, or maybe you put the appropriate weight on this last piece of news. Okay, so if you put the appropriate weight on this last piece of news, then this coefficient here in front of the nk+1 should be 1. If it's larger than 1, then you're actually going to overreact to the last piece of news. If it's smaller than 1, then you're actually going to underreact to this last piece of news. So what we're going to do now is we're going to zoom into this expression, and we're going to see under which circumstances it's going to be larger than 1, smaller than 1, and so on and so forth. So we're going to start by deriving predictions for this case rho equals 1. Remember, this is the case that I used in the motivating example. This is the case where similar news are embedded in similar contexts. Okay, and what you can see immediately from this expression is that this expression is then going to be larger than 1. Sorry, I should also tell you that Z denotes the number of past signals that were communicated with the same context as nk+1. Okay, and so what you can see here is that if rho equals 1, then this expression, because A, remember A is the strength of associative recall, R is the baseline probability of remembering, so all of these are positive, so this expression is going to be larger than 1. Which leads us to our first prediction, which is that expectations, if rho equals 1, then expectations should on average overreact to today's news. So there should be baseline overreaction on average. Now, if we look at the role of Z, then what we can immediately see is that the larger Z is, the higher overreaction should be. Okay, so what this implies is that overreaction should actually increase in the number of past news that took on the same signal realization, were communicated in the same context as today's news. Okay, so the more signals you've seen in the past that were communicated in the same context as today's news, the stronger overreaction should be. Finally, third, let's look at the role of the imperfectness of memory. Let's look at the role of this probability R, the baseline probability of remembering. What we can see from this expression is that overreaction should actually increase in the imperfectness of memory. Okay, this is easy to see if you look at the border at the limit case where memory is actually perfect. If memory is perfect, then you're going to always perfectly remember the signals you've seen in the past, and there's not going to be any overreaction because you perfectly remember everything. Okay, so there can only be overreaction in our model if basic memory is imperfect, and I think that intuitively makes sense. And then finally, we can look at this associativeness parameter, and what you can see directly is that the stronger associativeness is, the more overreaction we should see. So the fourth prediction is that overreaction increases in the strength of associative recall. And then now really finally, we're going to look at the case of rho equals -1. Remember, this is the case where in period 1, similar news are going to be embedded in similar contexts. But now in period 2, we flip the relation between news and context, meaning that now positive news are going to be embedded in the negative context and negative news are going to be embedded in the positive context. And as a consequence, what we're now going to get is that people actually underreact to today's news, at least on average. Okay, so depending on this rho parameter here, we're going to expect overreaction or underreaction on average. And so now what we're going to do in this experiment actually, and what I'm going to show you in the next couple of minutes, is we're going to try to precisely test all of these predictions. And in particular, we're going to try to exogenously manipulate all of the variables you can see in this expression here to really causally identify the role all of these expressions play for overreaction to news. Okay, so we're going to isolate the role of associativeness, imperfectness of memory, the role of rho, and so on and so forth. So let me now tell you how we try to do that. So let's talk about the experiment. The experimental design is relatively simple. And it's very similar to the, or it follows very closely the formal framework that I just told you. The task that subjects need to solve is they need to predict the stock market value of 12 hypothetical companies. The value of the company as in the model is going to be given by a baseline value V, and we set V to 100. So we say the baseline value is given by 100, plus the sum of all news about that company that were shown up to time t, so that were shown up to now. News can now either have a positive value of +10 or a negative value of -10. Positive and negative news were equally likely and were randomly and independently drawn by the computer. And all of this, and that's important, all of this was known to subjects. So the basic process which the value of the companies follow is entirely straightforward, right? It's a simple additive process. There's not even any uncertainty. So if you perfectly remember everything, then all you need to do is you take the baseline value and then you sum up all the pieces of news that you've obtained. Now we need some form of context, because remember the similarity of context is going to drive the strength of associativeness. So we need some way of embedding news in a context. And the way we do this is as follows. News were embedded in a picture and a story. And I'm going to show you an example of this on the next slide. The context was tailored to match with the type of news, either positive or negative. And importantly, there was a one-to-one mapping, as in the model, there was a one-to-one mapping between the type of news for a given company and the context. To be more specific, every positive news for company A, let's say, was communicated with the same picture and the same story, and every negative piece of news for company A was communicated with the same picture and the same story, but different ones than for positive news. Okay, so positive news for a given company were communicated with a given context. Negative news for a given company were communicated with always the same context, but a different one than for positive news. And then the same logic holds for all of the 12 companies. But of course, then for company B, every positive piece of news would be communicated with a different context than the positive news for company A. Okay, but again, for a given company, similar news were embedded in similar, or in this case, even identical contexts. Each piece of news accompanied by the story and the picture was displayed for 15 seconds on the computer screen, and we sort of pre-tested this to make sure that this is enough time to absorb and realize all the information. So here's an example of how this looked like. Think of the following situation. If you were a subject, you would have been told on the screen before that next you would see information about company K. So this is information about company K. And now the actual information is given to you on the bottom of the screen. It just says the value of the company decreased by 10 points. Okay, so that's the basic information, but it's embedded in a context, which is here a picture, as you can see, and a text. And this text simply describes why the value of the company decreased. Okay, so I mean, you can read it for yourself. The basic story is that the head of sales of this company is a choleric, and this creates all sorts of problems, and as a consequence, the value of the company decreased. Now, to make this point clear one more time, similarity of context here now implies the following. Whenever you would see a negative piece of news for company K, it would be embedded in this text and with this picture here. So this would be always the same context. If you would see a positive piece of news for company K, it would be embedded in a different picture and a different text. Okay, so again, this is how we implement this notion of similar news are embedded in similar, in this case, identical contexts. All right, let's talk about the timeline a little bit. The timeline was as follows. In the first period, again, similar to the model, in the first period for each company, subjects first saw between 0 and 3 pieces of news, and that gives us exogenous variation in the signal history. Subjects then had to provide an estimate about the value of that company, and this was incentivized. We basically used this estimate just because we wanted to see if subjects understand the basic setting of the experiment, because up to that point, everything subjects need to do is entirely trivial, right? They just need to see what pieces of news did I see for a specific company, and then they have to determine the value of that company. But it's entirely trivial. So, but the nice thing is, given that we elicit these estimates, we can verify if subjects understood the basic setting. Then there was a 15-minute break, and then in period 2, for each company, subjects were shown up to 1 additional piece of news. That's going to be the final piece of news, and we're going to be interested in how are people reacting to this final piece of news. Then we elicit second period beliefs about the value of that company, again incentivized with the binarized scoring rule as first period beliefs. And so these second period beliefs are going to be our key outcome measure, because again, remember, what we're going to be interested in is how are people responding to this last piece of news. So the final belief is going to be what we really care about. In addition, we also measure people's recall to sort of get a second outcome measure to really see, do the belief patterns we identify, do they sort of match the recall patterns we're getting? All right, so that's the basic experimental setting. So now let's jump to the results. Remember from the formal framework that beliefs in our formal framework are going to be guided by the following expression here. And remember also that the key expression we're interested in here is the coefficient in front of the last piece of news, in front of the nk plus 1. What you can see here is that this is an equation that we can actually directly estimate with OLS, right? So we can directly get an estimate for this coefficient here. So we can directly check, is this coefficient, for instance, larger than 1, which would mean there's basic overreaction? Is it smaller than 1, or is it equal to 1, which would mean there's underreaction, or people put appropriate weight on this last piece of news? Remember, the first 2 predictions we wanted to test is, first of all, in the main treatment, which is the treatment I was just describing to you, we should on average observe overreaction, which would imply that this coefficient is larger than 1. And then the second prediction would be that in this treatment, overreaction actually increases in the number of first period signals that have the same realization as the second period signal, which means it should increase in this parameter Z. Okay, so what we're going to do now is we essentially run an OLS regression, basically testing directly this, or basically estimating directly this equation here. And what you get here is the following. So what we're doing here is the dependent variable is now the second period belief, and we're regressing it on the second period signal. And this is going to be our main coefficient of interest. And what you can see from columns 1 to 3 is that this coefficient is significantly larger than 1. Okay, so it typically it has values about 1.1, as you can see here. And on the bottom, we are precisely testing this null hypothesis that and reject this null hypothesis that this coefficient is exactly. Okay, so this is the first piece of evidence that on average we actually see overreaction to news. Okay, now our whole story rests on this assumption that overreaction, at least in this case, is driven by associative recall. So let's directly look at our recall measure. Okay, let's verify if the overreaction I've just shown you is indeed driven by associative recall. So we use our recall measure for that. And the way to read this graph is as follows. Let's focus on on the horizontal axis, you see the numbers of first period signals. Let's focus on the case where this is 2. Okay, so let's focus on the blue dot here. What this dot tells you is essentially that these are subjects that have seen 2 pieces of news in the past that are in the same context as the current piece of news that they've seen. And we ask them, how many of these pieces of news do you recall? So the correct number would be 2, and we can see here that on average, their estimate is actually not so far away from 2. So they do a fairly good job. Now, the red dot here shows you the flip side of this. It shows you these are subjects that have seen 2 signals in the past that are different from the current signal. And we again ask them, how many of these do you recall? The correct number again would be 2. And what you can see here is that they remember significantly less. And that's exactly the principle of associative recall, right? Your memory accuracy is going to be higher for signals that are identical to the current signal compared to signals that are different to the current signal. Okay, so our recall patterns nicely match our first main finding that there's overreaction driven by associative recall. Let me actually skip the heterogeneity and move to the second prediction. Remember, the second prediction is that overreaction increases in the number of first period signals that have the same realization as the second period signal. The way we test this in our regression framework is that now, again, we have second period beliefs as a dependent variable, but now we regress this on the second period signal and an interaction term of the second period signal interacted with the number of first period signals in the same context. What prediction 2 says is that this interaction term should be significantly positive, because this would imply that the higher the number of first period signals in the same context, the higher our overreaction to news. And this is exactly what we see. Okay, so we see a substantial and positive and significant interaction effect, completely in line with our second prediction that overreaction should actually increase in the number of signals that have in the number of first period signals that were in the same context as the current signal. All right, let's move to our third prediction. Remember, our third prediction was that overreaction should actually increase in the imperfectness of memory. The way we're going to test this is actually we're going to exogenously set memory to perfection. Okay, so we exogenously remove or relax subjects' memory constraints simply by reminding them of their first period signal. So in the reminder treatment, as I just said, we reminded participants of their first period belief immediately before they received the second period signal. So in effect, we relaxed their memory constraint, keeping everything else constant. So we exogenously manipulate this R parameter here to see if now under perfect memory, overreaction disappears. All right? And that's exactly what we find. So what I'm showing you here is again a very similar specification. A dependent variable is again the second period belief. And our main object of interest is going to be the coefficient on the second period signal. But now we add an interaction term of whether you're in the main treatment or in the reminder treatment. And remember, we should see substantially more overreaction in the main treatment compared to the reminder treatment, because the prediction was that in the reminder treatment, overreaction should actually be substantially reduced or actually disappear. And so what you can see, or what this interaction term shows you, is exactly that. It shows you that there's substantially more overreaction in the main treatment where we did find overreaction compared to the reminder treatment where in effect we don't see overreaction at all. Okay, so this exogenous manipulation of memory, setting memory to perfection, actually entirely removes overreaction. All right, let's move to our fourth predictions. To our fourth prediction, we said that overreaction should actually increase in the strength of associative recall. The way we're going to test this is now we're going to try to essentially remove the scope for associative recall. We're going to do this in an additional treatment that we call the no-cue treatment. And the basic idea of this no-cue treatment was now that we sort of try to break associativeness. We try to remove associativeness, and we try to do this in the following way. We now communicate each piece of news with a different context. So it's now no longer the case that similar news are embedded in similar contexts. Now actually a given context never appears twice. even if the company and the type of news is identical. Okay. So again, it's no longer the case that every positive news for a company is communicated with the same context and every negative news is communicated with the same context. So via this exogenous variation, we now exogenously reduce the potential role of associativeness, again, keeping everything else constant. So what we should expect now is that in this no Q treatment, there should again be substantially less overreaction compared to our main treatment. We test this with exactly the same specification as we just saw in the reminder treatment. So again, what I'm showing you here is the dependent variable is the second period belief. And what I'm showing you here that the interaction of the coefficient of the second period signal is substantially positive and significantly positive, implying that there's substantially more overreaction in the main treatment condition compared to the no Q condition. In other words, exogenously reducing the scope for associative recall substantially reduces the overreaction to news, exactly in line with our fourth prediction. And so now finally, and then I'm gonna stop actually. Finally, let's look at prediction 5. Remember in prediction 5, we said that if the correlation between news and context is actually negative, expectations should underreact to today's news on average. The way we implement is we exactly follow the model essentially. We conducted a treatment that we called underreaction. And in this treatment, the first period proceeded exactly as in the main treatment. In the second period, the news were communicated on subjects' decision screens along with the opposite story and image. Okay? So now if there's a positive piece of news for a certain company, it would be communicated with the negative context, with the context that was attached to negative news in the first period, and vice versa. So now again, a positive news for company A was communicated along with the story and image that were associated with negative news for company A in the first period of the experiment. So again, in the second period, we flip the relation between news and context. What this implies is that now a positive piece of news is going to make you more likely to remember negative news from the past because of the similarity of context. And as a consequence, you're going to look like you're underreacting to the last piece of news. That's the basic intuition underlying this prediction. And let's see if we find evidence for that. Again, the estimation is exactly as I've shown you before. Again, the variable is a second period belief. And now what we see in columns 1 and 2 is that the estimated coefficient is now substantially smaller than 1, exactly providing exactly evidence in line with our prediction that now actually there's underreaction to this last piece of news. Okay, so depending on the relation between context and news, we actually see either overreaction or underreaction to news driven by this principle of associative recall. And that's all I had to say. So let me briefly summarize, and I think I'm already way out of time. So what we do in this project is we study the role of memory constraints and context in updating. We provide clean evidence, or we argue that we provide clean evidence that it's really associative recall that triggers overreaction. We isolate the role of memory and associativeness. We show that in which situations associative recall can actually also generate underreaction. And then we did not show you that we extend our belief patterns also to choice behavior, and we did not show you structureless. So thanks a lot.
Thank you, Florian. We have now time, roughly 12 minutes for some questions. In the chat, one question was asked by Jean Agenbach. Jean, do you want to raise a question yourself, or should I rephrase it?
So you can ask it.
All right, so Florian, the question is basically about the relationship between this study and your previous work on motivated beliefs, where you basically conclude that people might strategically forget or neglect particular signals when they form their beliefs. Is there a relationship, and if so, how?
Yeah, so I think in this previous paper, I looked at the relation of, or I asked the question: is there evidence that people sometimes want to forget certain things, right? So the hypothesis there was essentially that people might want to forget negative news, say news that threaten their ego or that threaten their self-view, and maybe they're more likely to remember positive news. But this is really driven by sort of motivated cognition. It's something that I want, essentially. What we here look at is something I think more basic, and in a way also more fundamental. It's really a very basic principle of how cognitively our memory works. And this very basic principle is, again, this associativeness principle. The important distinction is that in the setting we're studying here, there's actually no motivated reasoning at all. Our subjects don't care whether the value of these companies is high or low, because they don't own the companies. Their only job is actually to estimate if this value is relatively high or low. So there's really no motivation at all. And what we show is that this very fundamental principle of associative recall in such a setting where there's absolutely no scope for motivated reasoning, people then actually have a tendency to overreact to the last piece of news. So if this news is positive, they're going to be too optimistic, but also if the news is negative, they're going to be too pessimistic, right? So in my previous study, people would actually not so strongly react to negative news in the long run because they tend to forget it. This is also something that, of course, we don't see here, because here there's no reason for subjects to want to forget something. So there's going to be overreaction in both sides, to positive and to negative news.
Very clear. Thank you. Thank you.
Thank you.
Okay, there was another question by Daniel Barreto. Do you want to raise it yourself, or should I read it? Okay, so I guess I will pose the question. So the question is basically, it seems a key assumption in the model that the information is processed continuously as it arrives. Sorry, that's exactly the question. Here it seems that rather than processing information continuously as it arrives, agents are stocking signals that might depreciate with time, and then they retrieve and process them all at once when they make a decision. And the question is now, do we have evidence that this is really the case in reality? Or could it be that over and underreaction is a product of distorted but continuous updating processes, or that the observed associative recall is a product of your final belief rather than being its cause?
Okay, so I think I'm not sure I fully understand the question, but to the extent that I do, I do think that in our model, people actually do continuously update. It's just that, right, also in the first period, you continuously process the signals you obtain, and then actually you do form a belief. The crucial assumption is, of course, that then later in period 2, you're not going to perfectly remember your prior, right? If you would always perfectly remember your prior belief, then there wouldn't be no scope for memory distortion. So I think that's a crucial assumption. I think there's a ton of evidence from memory research that our memory is imperfect. So I think it's very plausible to think that we're not going to remember past priors. Of course, you can think of situations where people actually use technology, for instance, to remove their memory constraints, right? So if I'm writing down sort of the beliefs I've been holding continuously, then I sort of remove my own memory constraints, and then of course we're not going to see overreaction in our setting. So the situation we're capturing is one where you actually continuously update, but then over time you do forget the prior belief you were holding, and then you try to reconstruct the prior information you've seen from the past. So that, I think, is how we think about this.
Okay, there's actually another question on the no-cue treatment that is raised by several participants. And that's basically from the results that you show, it seems that subjects in the no-cue treatment are underreacting to the final piece of news.
Yeah. That's a great point.
Is this correct? And if yes, so how do you interpret this phenomenon?
Yes, that's a great point. So in principle, what we should expect is that overreaction is decreasing, as I said. But it is correct that we actually do see, or it does seem to be the case, that in the no-cue treatment, actually what we see, if anything, is underreaction. The way we interpret this is in a way some form of shading, if you will. So the situation in the no-cue treatment is quite difficult, because you're going to be in a situation where you're now facing a certain company, and we ask you, well, what do you think? What was the value of that company? and you're really not going to remember much from what you've seen in the past. And we think that this sort of creates a tendency to shift a little bit towards the baseline value of 100. And this form of shading would immediately generate underreaction. It's also something we see in situations where in the past, subjects have actually seen 0 signals. That actually also seems to create some form of uneasiness where people feel like, okay, what's going on here? I don't really have a clue. And that also generates a tendency to go towards 0. So there does seem to be some evidence for shading that is going on. In a way, it's even more remarkable, given that we see this form of shading, it's even more remarkable that associativeness seems to be so strong that it clearly dominates the shading effect, such that on average we see strong overreaction in the main treatment, even though there does seem to be some form of shading going on. But it's a good observation that we actually do see shading in these treatments.
I hope that this answer is satisfying. Then I will continue with another question by Tao Wang. And the question is actually relates to this distinction between good and bad context in the theory, but also in the experiment. And the question is now, in the real world, it could be, the classification could be different. Could be in terms of the scope to which information has an effect. For instance, idiosyncratic versus aggregate risk. And the question is now, would the memory recall framework also fit such situations?
I think of course, with the setting we implement here is very stylized, because the hope is, of course, to provide sort of proof of concept that associative recall can actually generate over and underreaction. I think in principle this notion of the similarity of context can be applied to quite many settings. Of course, here we implement in a very specific sense that we say that there's a class of positive news, and all of these news are going to be communicated with the same context, and there's a class of negative news, and all of these news are going to be implemented in the same context. But I do think this basic principle applies much more generally, but I would have to see the exact setting to sort of make an informed guess of whether I think this is also going to apply there.
Okay, and another question relates to prospect theory, which basically says that an imperfection of memory could be that we remember more negative news rather than, positive news, holding everything else constant. And
yeah. So that relates a bit to Jean's question from the beginning. I think one important thing to emphasize again is that here, from the perspective of subject, there's no positive or negative news, in the sense that it's not that for the subject a certain piece of news is positive or negative. They don't care about the news as such. All they care about is whether they can get a precise estimate of the value of the company. That would be different if, again, for instance, you would own the company or you would own stocks for the company. And of course, you do care whether the news is whether the information is positive, whether the stock increases or decreases. Again, we are in a setting where we call some news positive if their value is positive. We call some news negative if their value is negative, but they're not positive or negative in the sense that, people or subjects in our experiment might favor positive over negative news. That's not the case. And therefore, I think any patterns you might think about, either if, for motivated reasoning reasons that I show in my other paper, people might actually selectively forget negative news, or in other settings they might actually focus more on negative news. I think all of these things are very plausible and happen in many situations. I don't think they happen here, because here actually, again, from the perspective of subjects, there's no notion of positive or negative news except the sign in front of the pen.
Yeah, I think this question, or your answer, already answered another question on whether you think that your research in a Kosygin-Rabin framework, news utility, would you selectively recall something that is more convenient?
Yeah, so I think that's the sort of the same answer.
That is exactly the answer.
Applies. There's no convenient or inconvenient news in our experiment. So again, we sort of on purpose shut down any notions of motivated reasoning, because we really want to focus on this I think, again, in a way, much more fundamental, very basic way of how our memory works.
Okay, maybe a last question, and maybe a short answer to that. That relates again to this underreaction treatment. And there the effect size seems to be very large compared to the effect of association. So is that what you would expect?
No, so it is slightly larger. It's not something we expected. So it does seem to be the case. We conducted a separate control treatment because there's an aspect of this treatment that is a bit strange. We were worried in the sense that now actually the context no longer matches the last signal. So we have a control treatment that takes care of that. So I do think the evidence for underreaction is very clean. But we did not expect that the effect size would be slightly smaller. So this is just what happened.
Okay, thank you, Florian.
Thank you, Thomas, and thanks to everybody.
Thanks to all participants. If you enjoyed it, we are very happy if you visit us again on the next webinar of the cluster. Thanks a lot.
Great. Thanks, everybody.
Thank you so much, Florian.